We are here to present about the problem statement given by the Minister of Coal regarding telecommunications unit. So let me show you our PPT that we have designed. So this is the PPT that we have designed. So the problem statement given by the Minister of Coal is development of a telematic control unit for capturing vital data of a vehicle without using company fitted telemetry data port. So what the Minister of Coal want is to we need to make a telematic control unit, TCU it is called as, so which will give the vehicle's performance like engine performance, vehicle usage, and the performance of the driver, usage of the driver, how well he is driving. So all this can be done by using the TCU, which is a telematic control unit. So let me show you the flowchart like how we can implement this. So basically the TCU, what happens is the TCU will be get installed by some companies and some companies will not give a port to install them, so the problem arises there. So what I have thought is, like what we have thought is, we want to make a TCU kit but not an entire kit embedded at all. Like we will split the components, like we will split the sensors into different ways and we will install each of them separately, and after all that we will embed it into we will embed all them into a microcontroller, which makes a TCU kit. So you guys get it right. So coming to the flowchart, what will happen is, firstly coming to the procedure, here you can see that this is the start. So we will start this process by which this MQTT is a protocol which we know, which is known for the machine to machine communication process. MQTT is the protocol that we are using here, and when the MQTT connection is established from the vehicle to the respective authorities, then what will it do is it will check for the decision. It will take approximately 10 seconds. Then the performance of the vehicle will be sent through the cloud platform. Here we can use any platform, like we can use Azure, or we can also use AWS, which is provided by the Amazon. So here we are using the Amazon AWS, and see here this is the IoT rule. Like it is also a decision statement that we are giving IF3 we can use if then what. It is a open source website where we can do IF3 rule. So that's what I have placed here. So this is a AWS Lambda function which is provided in the AWS software, where the data can be stored and transformed, and it can be also be transferred according to our wish. It is based upon the GUI that we are giving. And coming to the data firehouse, where the data will get stored, and according to the data the Lambda function will be performed, and the data is present in JSON format. If it is yes, if the data is already present, then we will split the data according to the engine's performance, fuel usage, all this will be splitted. Then the dynamo will be used here, and we will give a authentication. See, like we are placing authentication here to avoid malware attacks, like prevention of hacking. So for that we have given a verification here, and we need to log in, like the authorities get to log in order to see the vehicle's performance. So for that we have provided the verification here. And if the verification it's got error, like if the credentials was wrong, then what will happen is immediately it will get stopped. And if the verification was passed, what will happen is then it will continue the flow. And these are the queries we can access through the GUI. It can be designed both front end and back end. We have CSC developers in our team, so it is quite easy only. So, and I am a EC student, and I can design these sensors and attach them to the engines. And there is also a triple candidate who has idea on all these stuff, and so we don't have any problem to embedded that. So also we have made this prototype, and we are up to 70% ready only. But the problem here is we didn't make the website right now. So if our idea gets shortlisted, then definitely we will make this last part. As you can see here, the query processing is still not made by us. So we can enter the query manually also. Like you need to provide a user interface. That's what we didn't provide. We didn't made that as of now. So here the user can give the input data, and here is the API, application interface gateway, and AWS Lambda. I have said before, it is used for as a cloud platform provided by the Amazon, where the data can be used as a query. Here you can give your query, and by which the process will go. and this is the basic idea that we are presenting right now. And this is the technology stack. See, for TCO we need line regulators, DC to DC converters in order to give the power, and global GSM also we can use here, or global navigation satellite system, GNSS also we can use for providing the location. We need to provide the location to the respective authorities, right? The vehicle location should be sent. For that we are using this. And RF power and antenna, this is for receiving and transmitting. As you can know, for long range distances we need to use the radio frequency powers, like the electromagnetic waves. That's why we are placing this. Microcontrol unit is the heart. Without it we can't control anything. So MCU can be made by we can make our own board, or we can also take many of the boards available outside. We can also use them. And CAN is for control area network, where we need to use it for communication, transmitting and receiving. That's why it is given as here transceivers. We need those. And the different type of sensors, as you can see, temperature sensors, voltage and current sensors are required to monitor the vehicle system. So these are the technology stack that we require as of now, and these are the cases that we are describing here. So what we can get a thought that what if the kit is removed by some mechanical engineer, the vehicle, what if the vehicle owner removed it, asked the mechanic to remove it. In that case we are also providing a unique code to prevent that, so by which an alarm will be sent to the respective authorities, by which we can control it. And malware activity will build a good firewall for that. Our CSC developers will do that. And when the cloud system, like many vehicles will be monitored by the authorities, right? So if the cloud system gets overflowed, what? This is a case, right? This is also a problem. So for that we are providing a live monitoring system where there will be no objection to this fleet's performance. We can always monitor the vehicle's performance, so there will be no overflow. And this is efficient in cost, and it will give good accurate results, because it is not only depend upon the entire kit. We are making it as a different parts. Like I have said before, we are not directly attaching the kit. We will first split them into the different parts, like engine part, fuel part, like next the vehicle performance part. All these parts will be first made and then embedded to the microcontroller unit, so that accurate results will be made. And easy to assemble, as I said before. Depend on central power system, because without power the MCU will not get worked. And this is like a practical, like if we install any audio system to our car, it will be continuously turned on. So the amount of power it will consume is more than compared with this central power system. So that is not any case, but I am just mentioning it regarding the power that was required to operate this MCU. And that's it as of now. So thank you very much. Hope this idea will get through to the SH 2023. Thank you.